Hi guys, this is lesson 97. It is called Recursive Rules for Sequences. Alright, some quick review. A sequence is an ordered list of numbers that follow a certain pattern or rule. So if we have a sequence here that gives us the numbers 3, 6, 9, 12, if you'll remember, the ... means it continues forever. So our rule, how do I get from 3 to 6? Well, I add 3. How do I get from 6 to 9? I add 3. How do I get from 9 to 12? I add 3. So you could guess that the next number in this sequence would be 12 plus 3, which is 15. 15 plus 3 is 18, right? And then it would continue forever. So that's an example of a sequence. All right, we've seen charts like this before. When you see the letter N, when we're talking about sequences, that has to do with the term position. So if we have the sequence 2, 4, 6, 8, the first term is 2, the second term is 4, the third term is 6, and the fourth term, I can't get it to go, there we go, the fourth term is 8. So if I fill in 1, 2, 3, 4, right? Then the next thing I'm going to look at is the term value, which we use the letter A to represent value. So the first term has a value of 2, if we read it from our list. The second term has a value of 4, then 6, then 8, and it continues indefinitely. All right, so some notation that is usually a little confusing, and we've seen this before, is when we write A sub N. Remember, sub means under, so the N is under the A. This refers to the value, or A, of the position N, right? So if I wanted to find the value of the fifth term, well, what's it going to be? In this sequence, because it goes 2, 4, 6, 8, my fifth term is going to be 10, right? The value of the sixth term would be 12. So today we're going to practice writing recursive rules so that we can figure out the value of the next term. All right, so we've seen these before. This is not a recursive rule, right? We're going to come up to those in just a second. So this is asking you, can you find the value of the nth term? All right, the value of the nth term is equal to 2 times whatever that term number is. So if I wanted to find the value of the 12th term, I'm going to take 12 and I'm going to plug it in where I see n. So the value of the 12th term is equal to 2 times n. And n in this case is 12. All right, so if we do that math, let me make that black. All right, the value of the 12th term is 24, right? Because 2 times 12 is 24. If I wanted to find the value of the 100th term, I would do 2 times 100. So the value of the 100th term is 200. All right, so those are the sequences or the formulas that we have learned about previously. Today's lesson is going to be all about recursive sequences. So these formulas show how a term relates to the preceding term. Preceding, if you think about what pre means, it means before. So this shows how a term relates to the term that comes before it. In these formulas, we always have to indicate the first term. So if we look at 2, 4, 6, 8, like we were looking at on the last slide, right? The first term is the number 2. So we have to make sure that we note that in our recursive formulas. All right, so here's a recursive sequence. So if I wanted to read this, I would say the value of the first term is 2. All right, A sub 1 just means the value of the first term. All right, and then if we look at this next part, this is where it gets a little confusing. Okay, the A sub n that we have right here means the value of the nth term. Okay, and that's equal to, this is the funky part, a sub n minus 1. A sub n minus 1 is just a weird way to say previous term. So I'm going to take the previous term and I'm going to add 5 because that's what this part of the formula is telling us. So the question is asking me to write the first 4 terms of this sequence. So the first term, a sub 1, is equal to 2. How do I know that? Well, they told me that right here. All right, so I need to find the value of the second term. So how am I going to do that? I'm going to look at my formula right here. I have a sub n minus 1, so the value of 2 minus 1 plus 5. All right, if we look at this part right here, the 2 minus 1 is 1. So I want to take the value of the first term, and I'm going to add 5. Well, I already know that the value of the first term is 2 because that's what they told us way back at the beginning, right? So this is going to be 2 plus 5, which is 7. All right, the value of the third term is the value of n minus 1, so 3 minus 1 plus 5. 3 minus 1 right here is 2. So I want to take the value of the second term and add 5. I know the value of the second term is 7 because that's what I just figured out. So 7 plus 5 is 12. To find the value of the fourth term, I'm going to take the value of 4 minus 1 and add 5. 4 minus 1 is 3, so the value of the third term plus 5. I just figured out the third term is 12, and 12 plus 5 is 17. All right, so if I wrote that out in a list, right, which I don't need to do that because I already answered it all. So my first term is 2, then 7, then 12, and then 17. So if I write that out in a list, 2, 7, 12, 17. How do I get from 2 to 7? I add 5. How do I get from 7 to 12? I add 5. How do I get from 12 to 17? I add 5. So all of this fancy writing is telling us is that I need to take the previous term and then I'm going to add 5 to the next term. Okay, so what if they asked me to write a recursive formula for a sequence? So recursive formulas have 2 parts. I need to write the first term, so the value of the first term, and I find that right here just by looking at it. The value of the first term here is 1. And now I want to write a formula for the value of the nth term. So recursive means I want to look at the previous term. So I'm going to write the notation that just means previous term. And what am I going to do to that previous term? So if I start with 1, what do I do to 1 to get 5? Well, I multiply by 5. If I'm at 5, how do I get from 5 to 25? Multiply by 5. And 25 times 5 would get me 125. So I'm going to take the previous term, which is this a sub n minus 1. I'm going to multiply it by 5. So I'm going to squeeze a 5 in the front here. When I'm writing formulas for recursive sequences, when I'm writing a recursive formula, I have to add the brackets so that I know they're mushed together. And I'm going to rewrite that so that it looks a little nicer. So my nth term is 5 times the previous term, right? So if I wanted to find the fifth term here, how would I do that? The value of the fifth term is 5 times the value of a sub 5 minus 1, which is 5 times the value of the fourth term, which is 5 times 125, right? What is 125 times 5? Well, if we do the math, we get 625. So my next number would be 625, and it would continue forever. All right, what about another one? Write a recursive formula for this sequence. So again, I'm going to start with the value of my first term, which is 2. That's what it tells me right here. And how do I find the nth term? So I'm going to look at my first term. How do I get from 2 to 4? I'm going to, what if I multiply by 2? All right, is 4 times 2 6? Nope, so that one must not work. All right, let's try again. How do I get from 2 to 4? I could add 2. All right, how do I get from 4 to 6? I add 2. How do I get from 6 to 8? I add 2. So to write this out as a formula, the value of the nth term is the value of the previous term, and I'm going to add 2, right? So my next term, if I continue adding 2, should be 10, right? That would be my 1, 2, 3, 4, fifth term. Let's see if that works. The value of the fifth term is the value of 5 minus 1 plus 2. 5 minus 1 is 4, so the fourth term plus 2. The fourth term is 8. 8 plus 2 is 10, so my sequence works. All right, which formula below generates the terms of the following sequence? So let's start by looking at the value of the first term. The value of the first term is 2, and all three of these formulas tell us that the value of the first term is 2. So that can't help us rule anything out yet. All right, how do I get from this first term here to 5? Well, I could add 3, right? 2 plus 3 is 5. Is 5 plus 3 11? Nope, that doesn't work. Okay, so how else could I do it? Well, I could plug in my numbers into the formula and see, right? This is term number 1. This is 2, this is 3, and this is 4, right? So if I'm looking at this first letter A, the value of the second term should be the previous term plus 5. All right, a sub 2 minus 1 is a sub 1 plus 5. The first term is 2, and 2 plus 5 is 7. Is the value of this term 7? Nope. So this can be ruled out. All right, what about this next one? The value of the second term should be 2 times the value of 2 minus 1 plus 1. 2 times the value of the first term plus 1. Well, 2 times the first term is 2 plus 1. 2 times 2 is 4, and 4 plus 1 is 5, right? That's 5. That works, so we're not going to rule it out yet. Let's check C just to make sure. The value of the second term is the value of 2 minus 1 plus 1. 2 minus 1 is 1, so the value of the first term plus 1. 2 plus 1 is 3, and my second term is not 3, so I can also rule out C. So that means that this recursive formula listed on B would generate the following sequence. All right, one more here. The terms of the following sequence are generated with the formula A sub n equals 4n minus 1. This formula right here is not a recursive sequence. They want us to write a recursive formula for this sequence. So remember, when we write recursive formulas, we're always going to start with the value of the first term, which in this case is 3. And the value of the nth term, how do I get from 3 to 7? I add 4. How do I get from 7 to 11? I add 4. How do I get from 11 to 15? I add 4. So I'm going to take the value of the previous term, and I'm going to add 4. Here is my recursive formula. All right, if you would like some additional problems to practice these, please go to your textbook on page 648 to do some extra practice problems. Your ALEKS homework, I can't guarantee that it will match exactly, but make sure that you know how to do these for when we head back to school. Thank you.